Hi everyone, in this video we'll be talking about 10.4. This is using properties of logarithms. So further looking at how logarithms work, and eventually this will help us be able to solve more types of logarithmic equations. So this is our first property. So this is the product rule for logarithms. If you have log base b of a product, m times n, then you can split that up into log base b of m plus log base b of n. So this product can turn into this sum. So in other words, I can rewrite this one as log base 6 of 7, since it's multiply, plus log base 6 of 11. That's all this is saying. And you can keep doing that as many times as you need until there are no more products left. So if you have log of 100 times x, you can split this up as log of 100 plus log of x. Remember that if it's not written and it says log, then that's implied to be a base 10. So you can actually write the base 10 if you want. It's the same exact thing. I'll go ahead and simplify this though, because log base 10 of 100, this is just the number 2. So we'd have 2 plus log of x. Okay, so that's your first property, this product to sum. There's another one. So this quotient rule for logarithms. So if you have log base b of a quotient, m divided by n, then this turns into log base b of m minus log base b of n. So the order matters there. We need to go upper minus the lower. So to apply this one, since I have 23 over x, I'll have log base 8 of 23 minus log base 8 of x. Here we have an ln. So I'll have ln of e to the 5th minus ln, that's the natural logarithm, right? That's base e. So it's same as log base e. And this would be of 11. And then just to simplify, ln of e to the whatever is just that whatever. So we would have 5 minus ln of 11. There's another property here. So if you have logarithm base b of m to the power p, that power can actually come out front as a product. So you can actually take this power all the way out front, and it's the exact same thing. So for part 2, ln of cube root of x would be the same as ln of x to the 1/3 power, right? Because the cube root, same as the 1/3 power. And then using the property, this 1/3 can just come right out front. So we can write 1/3 ln of x, same exact thing. So it's not as though those properties are always separated like that and kind of working in isolation. Often they're going to be working in tandem, such as this problem. So we're going to use kind of multiple properties in one to do what's called expand this. So when you're taking, for example, log base b of m times n equal to log base b of m plus log base b of n, when you're going this way, that's called expanding. when you're going this way, that's what we'll do next. That's actually called condensing. So we'll use a couple of these properties. So the first thing I'll do is actually split this up across the multiply. So this is equal to log base b of x to the fourth plus, since it's multiply, it goes to plus log base b of cube root of y, right? And we want to keep expanding this until there's nothing left more to do with respect to the properties. So this would be equal to log base b of x to the fourth plus log base b of y raised to the 1/3 power. So the only thing left to do is to perform that power rule. I'll bring both of these powers out in front. So we'd have 4 log base b of x plus 1/3 log base b of y. So on to condensing. This is where we're going kind of the opposite direction across the equal sign of the properties. So we want to put these together. If they have the same base, then we can put them together. Right? The only way we can go from right to left is if these bases are the same. Right? If this is log base 3 and this is log base 2, then there's no property that holds. So looking at part 2 here, I can write log base 4 of 2 times 32. Right, since they're both base 4 logarithms, I can bring them together and then multiply. So simplifying this, we get log base 4 of 64. Just checking in on what that might simplify to. Log base 4 of 64 is just the number 3, because 3 is the power that you put on 4 to make a 64. So this is actually just a weird way of saying the number 3. Okay. So page 165 now. It says write as a single logarithm. I'm going to jump down here to part 3. So the first thing I'm going to do, looking at this, is I'm actually going to bring these powers up, or these products back up as powers. Okay, so I'll write that as log base b of x to the fourth minus log base b of 6 squared minus log base b of y to the 1/2. I want to keep condensing until I have a single logarithm if possible. So maybe I'll go ahead and use the quotient rule now. Remember, so it said if you have log base b of m over n, then this is log base b of m minus log base b of n. So I'm using it this way, right? This condensed direction. So I'll have x to the fourth over 6 squared, which is 36, and I'll just write it as 36. So this is equal to log base b of x to the fourth over 36. And then I still have minus log base b of y to the 1/2. So now I have another round of this quotient rule because I have another subtract. So this will be equal to log base b of x to the fourth over 36 over y raised to the 1/2. Right, I take whatever's positive and I divide by this -1. Inverting and multiplying, this would simplify to log base b of x to the 4th over 36. And maybe I'll write it as the square root. Since the 1/2 power is the square root, I'll just leave it that way. All right, on to page 166. So let's condense this one. Again, the first thing I'm going to do is to bring these products up as powers. Okay, so I'll have log base 7 of x to the 1/4 minus log base 7 of 6 squared. I'll just write 36. And then minus log base 3 of z raised to the 10th. So right here I have log base 7, log base 7. So I can go ahead and use that quotient rule. So I can write log base 7 of x to the 1/4 over 36 minus log base 3 of z to the 10th. These two bases are different, so we cannot further condense. So this would be it. Okay. One more property, this change of base property. So if you don't have this calculator, there's a way around, because maybe you don't have this type of button. If you have this type of button, then you can just evaluate this by going log base 7 of 2,506. It's this strange number, right? Whatever. If you don't have this button, then you can actually get around it with this property. So what that is saying is if you have log base 7 of 2,506, then this would be equivalent to log base whatever. So I can use like log base 10 of the argument, so 2,506 over the log of that same base, right? A just needs to be the same. It doesn't matter what A you use. So I'll just do log of 7. So this should be the same, and you should have those buttons. You should have the log buttons at the very least on your calculator. So fraction, by the way, if you remember this number, we should get the same number in a second. So log base 10 of 2506 over log base 10 of 7, it equals, and it's the same number. I'll just write it to a few decimal places. So this would be about 4.022 if I round to 3 decimal places. All right, talk to you next time. Bye-bye.